Average velocity describes motion using displacement. So far, we have described motion using average speed. We asked how much total distance an object covered, and how much time the trip required. That gave us average speed, v bar equals delta s divided by delta t. But distance is not the same as displacement. Distance remembers the complete path. Displacement connects only the initial and final positions. So we can ask a different question. We are no longer interested in every turn, detour, or return. We ask, how much did the position change from start to finish, and how long did that change take? This gives us average velocity. In one dimension, average velocity equals displacement divided by elapsed time, v bar equals delta x divided by delta t. Imagine a person walking along a straight road. The person starts at xi equals 0 meters. 10 seconds later, the person finishes at xf equals 30 meters. The displacement is delta x equals xf minus xi. Here that is 30 meters minus 0 meters, which equals positive 30 meters. The positive sign tells us that the final position lies in the positive direction of the chosen axis. Dividing that displacement by 10 seconds gives an average velocity of positive 3 meters per second. This does not merely tell us how quickly distance accumulated. It says that, on average, the position changed by 3 meters in the positive direction during each second. Now reverse the trip. The person starts at xi equals 30 meters and reaches xf equals 0 meters after 10 seconds. The displacement is now 0 meters minus 30 meters, which equals negative 30 meters. Dividing by 10 seconds gives an average velocity of negative 3 meters per second. The negative sign does not mean that the person moves slowly, and it does not mean that the velocity is impossible. It tells us that the overall change in position points in the negative direction of the chosen axis. Average velocity can therefore be positive, negative, or zero. This follows directly from displacement, because displacement can carry a sign. Average speed is different. It is calculated from distance. Distance is a scalar and cannot be negative, so average speed cannot be negative. Average velocity is calculated from displacement. Displacement has direction and orientation, so average velocity can carry a sign. Now imagine a person who walks 10 meters to the right and then 10 meters back to the starting point. The person has really moved. The total distance is 10 meters plus 10 meters, or 20 meters. If the complete trip takes 10 seconds, the average speed is 20 meters divided by 10 seconds, which equals 2 meters per second. But displacement asks only where the person started and where the person finished. Those positions coincide, so delta x equals 0 meters. The average velocity is therefore 0 meters divided by 10 seconds, which equals 0 meters per second. This is the key contrast. The average speed is greater than 0 because distance accumulated along the path. The average velocity is 0 because the overall change in position is 0. Average speed remembers total distance in time. Average velocity remembers only displacement in time. Average speed asks how quickly distance accumulated. Average velocity asks how quickly the position changed from the initial position to the final position. Average velocity is a vector quantity. In one dimension, its orientation is usually shown by a sign. Positive 3 meters per second points in the positive direction of the axis. Negative 3 meters per second points in the negative direction. If we ask only for the magnitude, we use the length of the velocity arrow without its sign. Physically, average velocity describes how quickly the overall position changed from start to finish during a given time. It is especially useful when we care about progress from the initial position to the final position, rather than the complete history of the path. If this explanation helped, please like the video, subscribe to the channel, and leave your physics question in the comments. We will do our best to answer it.